Good morning, everyone. Please confirm is my audio is clear and also my screen visible to everyone.
Yeah,
Yeah, yes,
we
sir,
can
it's
hear
clear.
you, see you.
Yeah,
It's audible.
thank you, thank you. Okay, let's start. So whoever not joined yesterday, so please let me introduce myself. I'm Rajnikant Wadla and I have 7 plus years of experience into this platform, cloud automation and network automation and as well as machine learning and AI development. So I've been worked with multiple projects with multiple clients and I even have 4 plus years of experience in teaching. Not only here, so I'll be teaching at IntelliPart and Simply Learn and other big platforms also, but even at Narishati. So this is a short introduction about me and I'm going to be your instructor for this course. So this course is Multi-Cloud DevOps AI Mastery. So which I am going to cover all three clouds, AWS, Azure and GCP, and along with that DevOps, DevSecOps and SRE as well. Plus add-on advantage is AI. So this is the overview of the course which I'm going to cover, and whoever not check the syllabus, please go and check the syllabus at the website. Otherwise, if you ping over the WhatsApp, it automatically land on your inbox. Just check the syllabus. Okay. So this is sorry. Today is the second day. Yesterday we had a demo. So going to cover many tools on DevOps as part of DevOps. I'll tell you what are the tools we are going to cover. And so this is a formal PPT which I shown yesterday as well, and you can find it from my GitHub as well. So let me come back to my board. A quick recap. We have discussed yesterday regarding clouds and important clouds, three clouds which are AWS and Azure and GCP. Why these three clouds are important and why market is looking towards to do a multi-cloud strategy or connectivity. And we also discussed some points about the data center as well, right? So let me go over networking first. So I'll say anything you start, it could be a development, it could be a cloud, DevOps, AI, anything, you should perfect in the networking. So my every class will start from the networking itself and then I'll gradually take you into the cloud side. So we have to understand a base first, a baseline of the technologies and then only we can able to do it. And why networking first of all? Why networking? Let's say you are DevOps engineer, cloud engineer or SRE engineer. Whenever any outage happen or whenever any issue incident is created, you are the person who many people will reach out to you because you have good knowledge. People will think you DevOps guys will have a good knowledge. Cloud guy will be having a good knowledge. Even though there are network team, but you will be involved in the part of the incident. So that's where networking skills come into the picture, and this is a very good skill where you'll understand everything about the our IT infrastructure. Okay, let's talk about the networking. Before cloud technology came, what we have a data center. So data centers are different types of data centers we have on-premises data center, DC we call. On-premises means a customer take his own land and then or a rental based and then he will develop a building. Inside the building he'll keep all the servers, routers, switches, firewalls, storage servers, so many things he will keep in one closed area, and we call that as a data centers like this. A real data center will look like this. It's really look like this, and you'll be not able to hear the sound. You have to keep something at your headphones like rounded headphones, and then you have to enter into the data center. So because there will be a lot of noise inside the data center. There will be a lot of noise inside the data center. And all these are whatever you're seeing here, these are all the servers. Now we'll talk about the servers as well. What is the server and why we are using it, and what is the key role in this generation, means in this complete IT world. So everything that you are seeing, you are connected on the Google Meet and I am teaching on this something virtually, everything because of the server. Okay. All the servers placing in a order, and you can see in the right side, all these wires are connected. All these wires are connected. So these wires are connected with specific network configurations. With specific network configurations, which I'm going to tell you some topics which are related to your Docker container and Kubernetes container and networking part in the cloud. If your company is going to connect on-premises, sorry, data centers, so, and to your cloud, this all things are going to be involved. You need to know a basics about the networking, then you will understand those concepts when you are dealing with EKS, AKS, and where you are connecting your databases from on-premises to the cloud container-based applications. So this data center, let's say they are in a one region. So this could be in HYD. Let me duplicate. And this is in somewhere in the Pune, and this is in the somewhere in the Mumbai. Okay. Now I can call these data centers. So this is DC where it is primary, and DR disaster, and this is also I can call as DR. So like this I can have multiple data centers. If you see, multiple banks are they'll manage these data centers in multiple locations like this. in multiple locations like this. So there will be a connectivity called hub and spoke and full mesh. Hub and spoke and full mesh. That means each data center will connect to each data center. Let me draw like this. All these data centers are connected. So that means your single application may use from anywhere this data. Your application, when users are accessing, it can come from anywhere from the data center. Or there will be a like this hub and spoke. Hub and spoke means, so this will be your primary contact, means primary accessing point, and all other data centers are selective. Selective in the sense, let's say this is um, Chennai. So inside the Chennai, whatever the data here in this Pune, they don't want to sync them. So this connect will be happen in the banking. They don't want to sync them. So we call them as hub and spoke. Hub and spoke means this will comes into your Azure networking. When you're working on the Azure cloud, you might heard these words hub and spoke and full mesh connectivity. So these two terminologies will be there and these two connectivities will be there in the Azure cloud. Not only in the Azure, AWS also, GCP side also, but most of the times you will be able to find this type of connectivities on the Azure cloud with your on-premises. That means there will be a one single hub and all other are spokes. So these are all spokes. These are all spokes. Sorry. This all spokes will communicate with your hub, but your spokes will not communicate each other. These spokes will not communicate each other, but all these spokes will communicate with this hub. So this is the connectivity with respect to your cloud. In normal data centers also, so this is the thing they will follow. And here we have a types of data centers by including these connectivities. On-premises we said already, on-premises data center, cloud data center, co-location data center, edge data center, and hyperscale data center. So these are the types of the data centers right now in this world. So on-premises data center means where customer will build his own data center in his premises like bankings or JNTU or IS or railway, Indian railway things. Okay, all this Indian government are use their own data centers. And coming to cloud DCs, AWS, Azure and GCP. And co-location data centers are nothing but, so there are some companies, let's say I am the person, I have land, I have building and I have number of servers and I build them. I would like to give rent. I wanted to give some of 10 servers to the person who wants to deploy their services. So this is one type of business. Okay. I will create a kind of this data center and some rack servers are there like 10 servers. Some person wants to deploy his services. I'll give this 10 servers for rental based. So renting this rack server to someone else like NTT Data. NTT Data is a company where they do the same kind of thing with co-location data centers and edge location data centers. Something like that. We have Cloudflare. You might everyone heard about it. Cloudflare. Cloudflare or Akamai. Many people is an Akamai, or simple to say CloudFront in AWS. CloudFront in the AWS. So these type of data centers are edge DCs. Akamai is the best one for it, which is more secure, and Cloudflare also is the best and best now. If you go to Grok or if you go to any other website, there will be a one. Let me open. Let me open a grok.com. See, this is Cloudflare. So this is the data center. Now it is authenticating and checking am I human being or not, and it is sending this request to nearest data center. It is sending me to nearest data center. This is how it will check the edge locations. If you use Akamai, it do same. Whenever you use Cloudflare only, it will come up like that. But other CloudFront things, content delivery network data centers, they don't show this much latency where they will load the page and check you are a human or not. In background, it will be happen very simple and fast. So this is edge location data centers connectivity, which is used by many companies. Coming to hyperscale DC. Yes, Amazon it is having its own data centers. Google also having its own data centers for multi-tenant data centers. What does mean by multi-tenant data centers? Let's discuss that. I just wanted to give you overview over the data centers, and then we can move to the cloud side so that we'll have a very good picture why you are learning cloud technology and what is the problems of maintaining data centers. That's where our networking comes into the picture. Now, since I'm maintaining this, I would like to take two data centers. Not only in India, I would like to take in different countries. I would like to take different countries. So there is a application. There is a application, and this application I have in USA and I have in India. I have in USA and I have in India. So if I am maintaining data centers, physical data centers in different countries, and how this connectivity will be. Let me take India map. If you see, I'm sitting here. I'm sitting here in somewhere, and this application is deployed in the USA. So DCDR concept we are talking, right? The application is also running here and it is also running here. And I'm the person sitting in India. If I search www.abc.com, then my request, because of the Cloudflare, it will first reach out to the Mumbai data center here. If this Mumbai data center is not active, then my request will route from these gateways. To our India, we have gateways like this. So here, this particular company, let's say me as a company, what I will say, hey, I want connectivities from Airtel, Bharti Airtel, and also Jio, and also Vodafone. Vodafone. I want this three service providers connectivity who they will connect one country to another country. Inside India also they have a big network where they establish this network connectivity followed by some protocols. There are some protocols in the networking. Okay, we call the main protocol is BGP. When you are working especially with your data centers, whenever you're doing migration or whenever you're connecting hybrid cloud connectivity, data center to the cloud, so this BGP protocol you will able to see actually it will involve in between. You have to give these numbers. So there is one more name called ASN numbers, autonomous system numbers. If anybody worked on the migration, you will get to know these terminologies. Okay, I'll take these connectivities, and here you can see all these companies having multiple cables under the ocean. One country to another country, how we are able to do a WhatsApp chatting? Because of this submarine cables only. Okay, if my data center is down in the Mumbai, USA is this side, USA is this side, then my request will forward like this. My request will forward like this. Okay, if your data center is somewhere in the here, okay, or Pakistan, so your request will go like this. If this is down, then your request will go like this. Whenever your request will go like this to reach this data center, you will experience a latency. Latency means slow loading of the application. Your application will load very slow in the browser. You'll do refresh, 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 it will buffer, roll, 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 roll like that. So that's where your customers will log an incident to you or problem tickets. They'll create a tickets where SRE will come into the picture and they will work on it. Why it is happening? Why it is taking that much of slow loading? Customers will log these tickets and you have to solve within SLI. You need to know these concepts, right? This is only one case I'm talking. There are many aspects in between. Let me come to that point also, active Shiba. This is about the data centers if I maintain like this. Same configuration, cloud also doing. Same configurations, cloud also did. And they will maintain. Now, so let me call this is DC and this is DR, disaster recovery. As I said yesterday, a metro connectivity in the Hyderabad. I want whenever this data center down and this should be up. Otherwise, I want this both data centers should be up. That is active. That is active. That means your both data centers are active. Your request can go near to this location or near to this location. If you are travel and you are inside the USA, your request will go here. Or you are in somewhere, it will find the nearest location and it will forward there. So that's why many companies they will use their data centers whenever they may get any disaster. So this is the use case. So this is the use case. And inside this data center, there are many configurations with respect to your firewalls and load balancers. Now, I am as a customer, if I need to maintain these data centers, it is big headache for me. Power, engineering team, and cooling system, security system, monitoring system, SAN networks, okay, like storage area networks and SSD networks, object storage networks. All this I have to maintain inside the data center. So which has become a very big headache to the persons. Why? Let's say I have a small idea. I have a very small idea. I just wanted to deploy one food ordering app. Food ordering app uh, I would like to do it, okay? So in food ordering app, what I'll do, I'll hire a developer, and developer will do some code inside this his laptop, inside his laptop, and he'll say that yes, it is working perfectly, and I will check that okay, I'm satisfied with the code. I'm satisfied with the code, and then I will buy a server for him. I will buy a server. So what is this server? This server is nothing but compute part, where your code will run on a part, okay, some computational part. So this is a server. This is server. Inside this server, you will be having an operating system. Okay, you will be having one operating system. This is your compute part, a bare metal server. It is a bare metal server, or SSD, CPU, and memory. Okay, all these configurations will inside this server. So with this said, you will install one operating system on top of this. You will install your operating system on top of this. This is your operating system. That means Windows, Mac, or Linux. On top of this operating system, you will run your application. Here you will run application. This is your application. Application code, Java code or whatever. Okay, application. So my developer will run code in this server. Okay. So this server will have two IP addresses. One is public IP, one is private IP. Let's say now this server is capable of running my application with minimum requirements. Let's say it is having 8 GB memory and 2 CPU. Like your laptop only, 8 GB memory and 2 CPU. And there are multiple users who are accessing. I'm doing a testing now from Postman or from JMeter or from K6 load testing, from different tools. I'm doing a testing on this server. So this server is only able to handle 20 users in a 1 minute. So that means this server is able to allow 20 people inside this server. That means it can make a successful connections with 20 people in a minute. If one user terminated his session, and then it will allow another user to make a session. Nothing but to use the server. So is this server enough for me? If only 20 users are accessing, then this server is not enough for me. I have to increase this. I have to increase this, right? And like this, I will go for a entity data, or I can build my own data centers. In that case, For this server, let's say I buy this server by 30,000 or 50,000 and no use. After installing application, it was not successful. It was not successful. So I'm wasting the money and the device, right? What if I buy 3 4 servers like this? What if I buy 20 servers like this? So wasting of time and money. So that's how I'm fearing of establishing my own data centers, or if I go to the entity data, it is one best practice to go and take some rent. Now, this is the point where cloud came into the picture. So there are many problems our customers are facing when they have an idea and they want to become an entrepreneur by starting a business. That's where AWS come first into the picture of giving this cloud services. So we called cloud service provider, IaaS, PaaS and SaaS. Already platform as a service, software as a service present with the Azure and Google. Google is already giving you software as a service. Azure is already giving you platform as a service. AWS came with the strategy called infrastructure as a service. And then AWS also started giving platform as a service and software as a service, where a big revolution created in the market from 2011. And people have started using from 2015. Until that point, so many members don't know. Everyone only know Oracle Cloud. Nobody knows about these clouds or only Azure Cloud. So when AWS came and they started giving services and everyone get to know about it. Before that we have other two clouds called Tencent Cloud and DigitalOcean, or Alibaba Cloud also become a very good cloud service provider nowadays. So like that we have 26 plus cloud service providers in the market right now in the world. Among them, AWS, Azure and GCP are the top. Among of these three clouds, Azure and GCP, which is the toppest cloud? Means there is some priorities, right? There is some calculation. We can say which cloud is the best. Three clouds is having its own individual benefits and also features, but whenever the competition is running, always AWS is wins up. Why? There is a things called CAGR or Gartner Magic. According to their reports, AWS is having a more customers rather than the Azure and GCP. And now GCP is becoming more in competition to the AWS because they have new features and AML advancements are coming into the GCP side. So one company is always looks into the cost, reliability, security, and also connectivity level, and for their applications, which cloud is a better suit. Now, this is the point where we have to very uh, interestingly need to know. In AWS, I have one service which is best for my web application. In Azure, I have a service which is best for my storage. In GCP, I have a service which is best for my data orchestration, BigQuery like that. So if I take these two services in AWS, the cost is high. Or if I take this service in Azure, cost also high. If I take these two services in GCP, too much high in GCP, right? So these are the some of points where architects are thinking about it. Okay, they're fearing about the cost. How they can manage the CTO in over the period of time while we are building a structure or a skeleton of a cloud for our application over the period after 1 year, and the cost has become very high. What we have forecasted, what we have predicted, it is becoming more and more. So in that case, companies have started using the services from other cloud technologies. Let's say like GCP. I want storage service in Azure. I want data orchestration service in GCP. I want infrastructure in the AWS. So this is where multi-cloud things come into the picture. If you stick to the only one AWS, this is called vendor locking system. You will be locked to the one service provider. If you want to migrate this storage from AWS to Azure or Azure to GCP, so you need to again hire an engineering team, create a project, and then expect them to complete in 6 months and pressurize them. That's what where HCL, Capgemini all comes into the picture. That's why we call it as a rod project, because they have a very small deadlines and they wanted to finish. That's how they will pressurize us to the employees to complete that. When from 2019 starting using cloud is becoming more, and there is lack of awareness about the cost. Lack of awareness about the cost. That's how fintech, sorry, FinOps came into the picture. FinOps came into the picture, and this is separate engineering people who are analyzing the cost. And cost is becoming very high, and they're not able to run and running out of funds, and they started migrating to the other clouds. So this is where why we need to learn multi-cloud. Okay, one company will not end up with one service or one service provider. Now, since I have this many hurdles with my maintaining my own data centers, however, I'm going to the cloud side as a pay-as-you-go model. Pay-as-you-go model, even though it is okay, it's better rather than maintaining your own data center. But they also follow the same data center connectivity. Let me give you that example also. Yeah, so in your cases previously, what's happening? Sir, if they are working on the on-premises, then how we are able to do this DevOps works in Capgemini or in some other companies? We are getting some VDI connectivities and how they are making it. So this is your data center, and you will sit in the corporate area. Will sit in the corporate area. Yeah. So this is your building. Yes, you can ask the question, Prasad, in the end. So where you're sitting with your laptop, and you'll enable a VPN to this data centers. You enable VPN to this data centers, and that's how where you use Citrix. tricks. You will download this, and you will configure it with your office network, and you will also maintain one client thing in your laptop where Citrix client application, which is going to connect through your VPN to your data center. That's how you will able to see that VDI, virtual desktop interface, and you do work in this data center from your corporate area. If you're doing work from home also, this is how the VDI will connect. So this setup also we will do in the cloud. And I'm going to show you this, how this would be downloaded, how you will be connected, how these data centers are maintained, all this. So this is where your networking is important. You might going to be work on this project also. It could be anything. I'm covering everything, okay? It's in all aspects. So if I come to the cloud connectivity, I have a regions. Let's say, so this is UK region and this is Canada, China, some South Africa, North Korea, like this, India. So different regions are there. Different regions are there. All these are connected. All these are connected. And there is one common portal called console. We call it as console. aws.com, called as console. Azure, GCP, same way, www.portal.azure.com or gcpconsole.com or aws.com, like this. This will be a first it works from your one of the region. And what is mean by the region? Region is a logical boundary. It is just a logical boundary. So inside this logical boundary, I will be having availability zones. I'll tell you what is this. So these are availability zones. Might you people heard already about it. Okay, availability zones. So this collection of 3 availability zones in a area, I'll call it as a region. Let's say it is a Mumbai region in India or a Hyderabad region. Mumbai region means nearest to the Mumbai location, I'll have 3 availability zones. You can directly refer it as data centers. So inside one availability zone, there are sub data centers. Okay, like this. But this is not officially told by AWS. You cannot find this information. You can find this information, aged information, but you cannot able to find the information of sub data centers inside the availability zone. So the cluster of sub data centers, they're calling it as one availability zone, AZ1, AZ2, AZ3. So I can call them as 3 data centers only. So 3 data centers are at the same location? No. At least they'll maintain 50 kilometers or 100 kilometers between these data centers. Because at one location something happened, other availability zone is available for you to run your application. If this entire region is down, you have another region where you can take a backup. Okay. So these are the availability zones. If I go AWS regions and availability zones map, where is this map? It will open a map. There is a one interactive map. Let me open it. Let me search AWS regions and is it wait. I think they stopped this map. There is a good map actually. Fine. Let me open one of it. I'll take this one. Now you can see here. So these are all the map, okay, where regions are available. Mumbai and Hyderabad is not updated. It is an old map and different country and different regions. In each region, there will be a availability zones. So that's where the map, global infrastructure map has to show the date and the time, sorry, date only, and also there will be a availability zone information. It's need it it will be available from the this link only. They have updated the console. North America, Middle East, according to the, so these are the geographic. Oh, like this they have updated. If I select AWS Gout Cloud US East, so this is the data center. So AWS is also giving a cloud for the government USA And same way Azure also giving to the government a separate data centers. If I click on Central Canada, this is the location, Canada West, Mexico, and let me come to Ohio region. So here it is. Let me click on Asia Pacific. So when you click on Asia Pacific, inside this Asia continent, we have Mumbai and we have Hyderabad and we have Hong Kong, Malaysia, Singapore. So like this. So these are all the data centers, means regions. Inside this region, we have a data centers. Okay, like this. So this is where we are logging as a user. We are logging as a user and creating a servers. We are developing our infrastructure. We are configuring our network. We are configuring our applications, and then we are deploying in this cloud. It's quite easy, right? Rather you are going and uh, connecting a plug to your server, login, doing something manually. It's quite easy to go to the clouds. That's how these all customers are interested to moving towards the cloud, and they already moved most of the people. As of now, 72% of cloud migrations has been happened. So rest of some 38 things, 28 things are there. So which they are not migrated still. Some of them are government only, and some of them are because of the dependencies. So most of the companies are already migrated. At least they are maintaining 22% of hybrid connectivities in the world. Okay. So this is why you need to learn cloud first. So always learning DevOps as a single course is not help you guys. You have to learn cloud and DevOps mandatory. Otherwise you will not able to uh, pro in your way. You have to know the cloud and you have to know the DevOps. After cloud only, DevOps will come into the picture. And then we will create our AWS account, our Azure account and GCP account, and we'll start the classes from next onwards, from next class onwards. If you have any queries or if you not understand any point which I am teaching you right now in this class, please raise your hand and ask me. Or do you want me to cover anything more? I'm happy to cover it now. Yes, Shiba, you can unmute.
Sir,
Yeah.
sir, in the active passive or passive active setup,
Mm,
so how much time it will take to become a active from the passive stage? And is this timing depend on the RPO and RTO?
exactly. So RTO is nothing but
Recovery time objective,
yes, recovery time objective and recovery objective.
point objective. Yeah, yeah.
So this is time and this is point. Okay. So in your recovery time objective, whenever you perform any failover activity, how quickly the DR is picking up, that is a matter. So most of the times it has to pick up in just 1 minute or highly in cases 5 minutes. In between this range, if you are defining your DR to be set it up in pickup just 1 minute and you are highly good at the your passive to active, time respective. If you're not, and it is moving more than the 5 minutes, and you will be in a very uh, lost stage. It shouldn't be like this. So you have to reconfigure your things. And coming to the RPO. So RPO, how much data you are getting lost over this period. Some incident happen, and your two applications are from the two regions, and users are logging into your application site, and the sync is not happen. How much data loss you can accept? Let's say you given this project to the TCS. Okay, TCS people, they said that we are giving some agreement, SLA agreement, and our team, engineering team, is very high qualified team, and we will be able to solve your problems within this SLA time. And we will be defining SLI, SLO, and SLA things, indicators, objectives, and agreements. And some incident happen, and where are people jump into the nothing but our SRE engineers are jumped into the call. We're discussing what's happened, what is the issue, the root cause is finding out. So since we already done some performance testing, right? Performance testing means failover testing. In the time of failover testing time, my recovery time is just 1 minute. And in that case, how much data loss is happening? That I need to accept. Okay. How much I'm doing when two DBs are there, example. You're doing replicating between this active to passive, active to passive. In that case, if a sync is missed, if a replication frequency is missed, then how much you are accepting to do data loss? If your RPO 15 minutes 15 minutes of async or a cold standby or a warm standby, acceptable, because default time, basically it will take this much of time to the network to faster their packets in between or to sync in between. So network itself take that much time. So that is acceptable minutes. The data after 15 minutes can be sync in between. You can also experience in your real world while you are accessing a Flipkart or any other application, sometimes it will go down, and where it is not showing you some proper data, and after some time it will show that. How come? If something incident happen over in particular region, it will take some time to sync. Or some bug also is a problem. You don't know it is a because of bug, you don't know because of cache, you don't know because of replication frequency. So in that cases, what is my acceptable data loss? So the 15 minutes is the data loss. Where your hot standby means the first priority of the standby is the 15 minutes. If you're more than the 15 minutes, then you have to work. You have to find the root causes, why it is happening, or any more optimizations you need to do. Like this, you have to go on it. One more thing. If your high availability is there in between the bankings just only 15 seconds, your RTO should be your recovery point of time. Here we sent 1 minute, but in the banking, RTO will be just 15 seconds. They won't accept more than that. They won't accept more than that. So this is in your hard standby strategy. Or how you will do this failover testing at your data centers. So you need to make a pacemaker or keep alive things. With them, you can do this failover testing in order to find your RTO and RPO in your active passive or passive active or active active strategies. Did I answer your question, Shiva?
Yeah, got it. One more question is there. Like, let's say my application is running on AWS on a
Mm,
single cloud.
Hmm.
So later I want to, let's say I want to change my cloud. So is
Hmm.
it better to migrate this application to that other cloud, or is it better to start from the scratch in the other cloud? Let's say on Azure or GCP, I will start from the scratch, like everything. I will build the servers and all the things from the scratch, or should I migrate from the AWS to Azure?
Okay, good question. See, if I have the best one is, since I already one, let's say one single service will take, easy to. This is in my AWS, this is in my Azure. I don't have interconnectivity things and broad connectivity things. Means I'm not using different services. Only one service I would like to. Sorry, this Azure. Okay. The best way is to do refactoring the existing application. So there are recreate, lift and shift, and rec- uh, some five strategies will be there. Okay. So the best strategies are the lift and shift and granular migration or refactoring or recreate. Let's say I have one service running here. I have one service here. What I will do, first, instead of recreating or building everything from the scratch to this Azure side, I will refactor my existing application. That means I will try to move a smaller amount of workloads to this side, a smaller modules. Like if you have a multiple services, login, payment, user, or any other Docker container, or your EKS, Lambdas, other things you have there in the AWS, and you want to move them to this side, so you will divide them into a smaller modules, move each one, and don't disturb this existing connectivity. Don't disturb this existing connectivity and make a one more parallel connectivity here of, this is nothing but the refactoring the application. Okay, and then once all the data is moved, you can make use of this one. Instead of you're creating this everything from the scratch and you're downing this application and you're making it up, it will take a longer time, complexity in the moving. Or if you're doing recreate everything from the scratch, it will also take a longer time, and you may miss some dependencies. Nothing but you're trying to duplicate this. So when you're trying to duplicate this, go each module in a small module way. Duplicate this small module one time, and then duplicate this small module second time, and then duplicate this third module in third time, and then make the connectivities. In that way, it is best to go with the refactoring your existing and creating in the Azure. Or do lift and shift. Lift and shift also is similar like that, we can say. You are just lifting small modules and shifting into the Azure. You can do through the Terraform or OpenTofu. Very good to go with that. Instead, you're doing manual. So if you're maintaining a Terraform or a OpenTofu, what happened? You just need to change some module configurations. That's it. It will be created in your Azure side. You just need to only change the providers. You just need to only change the syntaxes and the model configurations and configure your state things in the Azure and create a one more workspace and come to the Azure side. Getting me?
Yes, sir. And one more thing,
Hmm.
like how can I transfer my backups? Like let's say my backups are available in the S3. So in
Hmm.
the Azure it is like data storage.
Hmm.
So how can I transfer those things?
See, transferring is there are different methods are there. Okay, to the Azure to the your AWS. You can do AZ copy. AWS is there, Azure is there. You can do AZ copy. You can do AWS CLI copy, or you can do R clone, or you can do Cloud Endure is a tool, or Cloud Sync, or Carbonite. These tools you can use to move from AWS to Azure side. So best to go with, if you wanted to move to the Azure side, the best to go is AZ copy, because quite easy to use. If you are going with Cloud Endure or a Cloud Sync or Carbonite tools, uh, setting up the configurations is quite this one. Or you can use R clone. It's good to go with. Automatically it will download from your AWS, and you maintain one server and configure this side Azure and this side AWS. This tool, if you're doing this R clone, it will come here and it will push it here. You can do like this. So this is the best method. If you use any other
Okay, sir.
services over the cloud side to do automation, Lambda, other things, it will cost you. Taking a single server running this will be very cost saving and effective.
Okay, sir. Got it. That's it from my side.
Cool. Anyone having any questions? I can't see any hand raised. Okay. So one more thing, from tomorrow onwards, 7 p.m. IST, the regular classes are starting. So please join and ping over the WhatsApp, so that whatever the information you need, uh, admin will pick the call and give you the information about it. Admin name is Naveen. So you can, whenever you call, say, are you speaking with Naveen or not? So, and then whatever the questions you have, you can ask him. Anything else that I would like to answer? If you are new today, you can raise your hand and ask the question if I'm missing anything. Cool. So 1 minute. If you are new today, if you not watched the class of yesterday, just please check your chat. Just a minute. Please watch this recording. So it is available in the YouTube. Any comments from the YouTube? I didn't see any comments from YouTube. Cool. Yeah, Mohan Sai, we will cover GitHub Actions, Azure DevOps, and GitLab CA also, and Jenkins as well. The same link for tomorrow 7 p.m. as well, 7 p.m. IST. You can log in on the same link, and for your enrollment, like your payments, please speak with Naveen and you will get a classroom access where you will able to see everyday notes and the recordings, and you'll be added into the WhatsApp group automatically where all your batchmates will be there and you can able to communicate with me directly. Cool. Any questions? If not, then we can start our regular classes from tomorrow onwards, Monday. Have a nice weekend, everyone. Thank you for joining.
Thank you, sir.
Thank you, Rajni.
Thank you.
Thank you, Rajni.